Hi folks, and welcome to a quick look at the hardware that I'm going to be using. Now obviously you're not obliged to use the same hardware. This is just a look at what I'm using and why I'm going to be using it. We're going to kick off with a HP ProLiant microserver. This is the N54L. It's a dual core 2.2 GHz processor, low voltage and all the rest of that jazz. If you open it up, you can see inside that it has 4 RAID bays here. Well, they're not really RAID bays as such, they're just SATA drives. They're non-hot plug and play, although supposedly it is supposed to be capable of that. Are they already? No, they're not. Come on, open up. There we go. Simple holders, you just install your drive, slide it in, that's it. There is, if I can manage to get this top open, you can see that there's another bay in here that can be used for a CD-ROM. I'm normally going to be using this for the operating system drive in here, and the spinning rest is going to be in here. There's one fan, typically at the rear, 120 centimeters, that's what keeps it cool. The motherboard, let's have a look. Hello computer. Okay, I'm going to have to get a screwdriver to that. But the motherboard slides in there. You've got the usual connectors, including one to the power supply, which is in here. The power supply I will be replacing because they're typically very noisy. Also, they're not exactly the most efficient in terms of power transformation. Coming to power, I'm going to be using one of these. This is an external 160 watt transformer. So by transforming outside the case, we're keeping a degree of heat outside the case. That connects through a 12 volt cable to this, which is a Pico PSU. Now you probably can't see that, but that is a plug which goes directly onto the motherboard, and there's various electronics in here, which also deliver to the various peripherals. So it cuts down the 12 volts to 5, etc., whatever it needs. However, because the motherboard itself is actually so high up, let's just get that out of that. Because the motherboard itself is so high that the height here, between here, is so short, we're going to have to use an extension cable. So what I'm going to do is put that extension cable in the motherboard, feed this cable around and up into this bay here. That's basically how I'm intending to do that. So the original will be taken out, replaced with a Pico PSU connected here, and it will be fed by 12 volts outside the case, which should save us a degree of heat. Now, obviously there's going to be an ECC RAM upgrade going in here. This is 8 gig from another server of ECC. I've got more elsewhere that I'll be using once this has trialed itself. For the build purpose, for the test, we'll be using 2 of these Seagate 80 gig hard drives. What I'm going to do is put one in, install on one of these. Then once it's in, I'm going to show you the mirroring process to mirror the operating system and the boot sector to the second drive. So that if one drive fails, you have a complete bootable hard drive that can also continue on. The other thing about this, if you have a look at the back, you can see there's various connectors, but not that much. You've got 2 half-height expansion bays in here, an eSATA network, which is gigabit, 2 USBs, and VGA. Not the best. Now, obviously, I'm going to be hooking this up to a KVM, and the KVM that I'm hooking up to and the monitor that's attached is digital only. So even if I were to get a VGA to a DVI conversion system, it wouldn't work. I mean, conversion in terms of connector. So here I have, interesting. I thought this was supposed to be pre-used, but it doesn't look like it is. I need a pair of scissors. Where am I going to get a pair of scissors from? Over there. Bear with me a moment. Just got to step across the camera. Yike. And this is a half-height graphics card that I'll be using. It's also the AGP version, which will match with the motherboard. I've already got one of these in another HP server. This is a What is it? I've forgotten what it is, and I bought the damn thing. I've completely forgotten what it is. So this has got to be fitted in there, which will allow us DVI output from the system. And the other thing that's going to happen is a hole's going to have to be drilled in one of these plates, so I can fit in the 12 volt socket that's on the end of the Pico PSU. So that's just going to be drilled and fitted in there. Obviously with one of these it's a bit awkward because this is the release mechanism here. And trying to keep anything in here, oh, there's screws in here. Trying to keep things solid in here is a bit difficult. So if I drill a hole in this one, I should be able to keep it stable. In fact, I wonder if I can do that on the other one. Haha, I'll have to give that a look. So that's roughly what we've got and where we'll be going with this. This is just used to keep the keys safe. A few things about these is that one of the things I do is typically take the LED the heck out of behind here, because this is just way too bright. What am I thinking of? Oh yes, the Pico PSU, by the way, is going to be wrapped in this. This is a film which is obviously non-conductive, but the other thing about this film is that it's heat resistive. This is actually a colour temperature film which would go in front of some of the lights at a theatre. So this can take a fair chunk of heat, because you know they've got a powerful theatre light and this sitting straight in front of it. That's going to get an awful lot of heat. So this is what the Pico PSU is mostly going to be wrapped in, but obviously with gaps for air. And that should keep it happy and safe. Inside this door, I can actually take this door off like this, and you can see that one of the things they do is you've actually got all the screws needed lined up in here. The cost for this is about 170, 180 pounds for the base N40L. They vary in price quite a bit, so it's worthwhile shopping around. Sorry, this is the N54L. This is just over 170 with no hard discs. Obviously it's pointless me getting anything with hard disk, but you'll find them out there in various configurations and various models. It should come with about 2 gig, but you can add on to that if you want to get more gig. The rule of thumb when you're dealing with ZFS is 1 gig of RAM for every terabyte of disk space that you're using. So that's a rule of thumb, and ECC RAM is not cheap, so you can easily chuck another 50 to 80 quid on top of that, depending on how much of that RAM you want, and try and buy some quality stuff. This is Kingston, I think. Yes, this is Kingston. And also you've got to watch out for fraudulent memory, you know, rip-off and all the rest of that jazz. One of the other things is that the power is obviously split. So the power comes up here from the power supply and then split via a number of different splitters in order to go behind here to power each of these bays. Bit of a pain, but there you go. You've got 4 USB sockets at the front. That's pretty much it. If you can do with VGA, you're okay. One of these sent me back a tenner. I'll have to find out exactly what part number that is. Then it's up to you. I'll be using an SSD in here for the OS and spinning Rust. That's roughly about it. One of the main things is that using ZFS, it's hardware independent, so it'd be possible for me to take the drives out, put it in another, even take the operating system out, usually put it in another machine, and then the whole thing should spark up and be functional. So if this chassis ever fails for any reason, I should just be able to port to another machine that's got enough connectors and at least get the system back up and running and have access to my data. So I'm going to do that. I'm going to make these changes. And the other thing that I'm going to do first of all, however, is spark this up and change the BIOS. Now, a link in the bottom and the descriptor of this video will be to Brian's Tech Tips, and there he's got the latest sort of fanware, if you like, BIOS update for this, because typically these servers come with a bit of restriction on them. Stuff like the eSATA might not work properly. If I've got that set right. The eSATA might not work properly or at proper speeds. I think there's also a speed restriction on. Come on, get in there. though. Got it. There's a speed restriction on SATA 5 which feeds this. Also there's no hot plug and play, but also among the various things that the BIOS update is supposed to provide is the ability to hot plug and play in the BIOS. Obviously I'm switching over to the Pico PSU, so I'm not going to be using that feature of the BIOS, but I do want the extra speed on the eSATA, which is where I'm going to plug the backup drives in, and I want a decent speed on the operating system hard drive, so that's why I'm going for the BIOS update. So I'm going to do that and fit everything. I'm only going to fit the one hard drive at the moment, and then get the operating. Then we'll go through the BIOS settings and we'll get the operating system loaded. So see you on the next video. Okay, at this point the BIOS has been flashed, and one of the things that you need to do in the chipset for the on-chip SATA configuration is change a few options, otherwise you may have some problems with the eSATA port. Among them, you need to make sure that the IDE combined mode is disabled, and you probably want to switch on ESP on all ports if you are using the eSATA. That's roughly what you should be looking at.